I'm going to throw some serious money at funding for looking at things beyond space-time. Not only do I think that would just be an incredible project, I think that you could derive technology from that will change the course of human history. Quantum entanglement, Bell's theorem, okay? Bell's theorem are foundational concepts, or quantum entanglement and Bell's theorem are foundational concepts in quantum mechanics that have profound implications for our understanding of the nature of reality. They challenge classical intuitions about how particles interact and the limits of information sharing across space and time. Now, important to understand the definition of like locally real. When we say like the universe is not locally real, real means objects have definite properties independent of observation. We know that not to be true now because of the two-slit experiment and Wheeler's delayed, right? The Wheeler's delayed experiment. Delayed choice experiment. So we know that real objects have definite properties independent of observation is not accurate in those experiments. Been quantifiably proven through scientific experiments. Okay. Now, local means objects can be influenced only by their surroundings and that any influence cannot travel faster than the speed of light. Okay? So if the universe is real and local, which is how space-time functions, then particles that are far apart from each other cannot be affected by anything faster than the speed of light. Okay, but look at what Bell's theorem talks about. Quantum entanglement is a physical phenomena that occurs when pairs or groups of particles are generated, interact, or share spatial proximity in ways such that quantum state of each particle cannot be described independently of the state of the others, even when the particles are separated by large distances. The entangled particles become a single quantum system. So, correlated properties. When particles are entangled, measuring a specific property like spin, position, or momentum of one particle instantly sets the corresponding property of the other particle, regardless of the distance between them. The effect occurs instantaneously and does not involve any known mechanism or signal traveling between them, leading to what Einstein famously derided as spooky action at a distance.
Agree. It's like how? Why?
Well, that would say that space-time is not fundamental.
Yeah.
Because it's conscious observance of a parameter of the particle that has causality on the other particle can be an infinite distance away and happens immediately.
Yeah. Yeah.
They call it quantum entanglement, that somehow these two particles are entangled quantumly through something that can't be explained in space-time and only interacts when consciousness observes it, when it's measured. So,
how much of this do you find to be scientific?
All of it. These are replicatable scientific experiments. Quantum physics?
Well, which is like, but when you layer on the fact that some of these things cannot be true without consciousness, it's like, does that then become spiritual matter versus scientific? Understanding that we really, truly don't understand fully.
You're saying you want to call quantum physics, what's the term we're using for things that are not? You want to call quantum physics? Yeah, you want to call quantum physics metaphysical? The measuring of particles?
I don't think so.
No.
It's very physical.
It's
but
scientific.
What I want to call is the fact that does the science even matter because consciousness transcends all?
Well, listen. So
right? It's cool. I wrote down, it's cool to see that Luke has started to use science to back conviction and faith in God.
Yeah.
Because not that long ago, I would go full analytical science guy on you, and you would be faith-based. Very much faith-based.
Sure.
And you could convince me through conviction that that is the way.
Yeah.
Like the best way to know absolute truth.
Theological arguments or things of that nature. But
So
The more I dig into it, the more I realize that all truth is circumscribed into one great whole, which is what the scriptures teach.
yeah,
So,
including science.
yes. So whether you want to find it through quantum physics, or you want to find it through anecdotal evidence of testimony, or you want to find it through revelation received in matters of scriptural things, I believe that all of these truths come together. And that's why my inclination that space-time is not fundamental, right? I immediately realized when thinking about it, first off, that space-time cannot be fundamental if God exists. And my experience tells me that God exists.
Yeah.
So I come at it through a bit of a skewed lens, but I did want to see, can my hypothesis of God existing be proven in science? And what I've found is that the more you dig, the more convincing science becomes to me that God does exist.
Yeah.
Space-time's not fundamental. The creation of the universe was not an accident. The infinite complexity of the human mind and body is all testimony to the grand consciousness in the Markovian dynamics models of Hoffman that show that space-time is not fundamental, that consciousness is more fundamental, and it can be observed in quantum physics, which essentially breaks down space-time, tells us that space-time is doomed. Characteristics of particles that are transferring information beyond the speed of light, that are going back in time and making changes based on conscious observance. I mean, all of these just incredible scientific experiments.
Is there a chance that consciousness transcends all so far that space-time may just cease to even exist?
Well, I mean, you start to think about some of the implications of being able to operate outside of space-time. Right now, we talk about being able to travel to distant stars as being impossible. Because light, in the grand scheme of things, what is light? 186? Is it 186 million miles per second?
Not sure. Hey Siri.
Yeah.
How fast does light travel?
Light travels at a speed of approximately 186,000 miles per second.
186,000 miles per second. Yeah, okay. So 186,000 miles per second. In space-time, that's fairly fast. But in the grand scheme of things, we're talking about galaxies we'd like to observe that are 400, 800, 600, a trillion
Light years away.
light years away.
Yeah.
We would never be able to travel and observe those.
Yeah.
But outside of space-time, if we can learn how to travel outside of space-time, to move like some of these particles that are moving at the speed of light, to take the quantum entanglement of Bell's theorem and be able to impact particles that are 100 million light years away instantaneously, we could move ourselves to places and see things and impact things instantaneously across large distances. I believe that if we can drop the paradigm that space-time is fundamental and open our mind to an idea that there are things like the amplituhedron, which have highly predictive capabilities and live outside of space-time, that we can move science drastically. I mean, you think about the implications of technology, of things that are operating outside of space-time. Travel, thought, communication. I mean, it becomes brilliant. But one has to be able to shed these false notions through their perceived reality of truth in order to get in contact with these more metaphysical concepts, because metaphysical just means outside of space-time. These metaphysical truths, which would enable us to push man's discovery of what's possible well beyond the general theory of relativity. To me, that seems like such a provoking endeavor. Listen, I'm coming out of my venture fund in a year and a half. I'm going to throw some serious money at funding for looking at things beyond space-time. Not only do I think that would just be an incredible project, I think that you could derive technology from that will change the course of human history.